Hey, what's up, guys? Yeah, so today I want to talk about this strange algorithm called Strassen algorithm. So basically, when I mean the first time I see this algorithm, I feel so amazing that how can someone come up with these type of things? Okay, so this is also the one of the not so fast, but the fast always basically the interesting matrix multiplication algorithms. Okay, so in this video, I will dive into the proof and also help you to get the idea. Okay, so idea is that let's say you take n by n matrices, it's A and B, right? And what is the list? What is the multiplication that the number of operation, the number of the least multiplication that you need to do, right? So if you times this to this, that it takes n, right? So total you get some n square number, right? So the total will be O n cube. Okay, so this is the standard. Okay, and also there's a lower bound, right? So lower bound is that you have got a numbers n square, right? So you need O n square. Okay, so you know that the fattest the something, right? The optimal matrix product, right, should be fall into this region. Okay, so the strengthened algorithm is somewhat that one can achieve. So one can achieve alpha to be log 2 7. Okay, so I think which is 2.8 something. Okay, so let me explain the algorithm. Okay, so algorithm looks like so without loss of generosity, so I can assume that the matrix is not just is 2 to the n times 2 to the n. Okay, so if it's not, then I can pad with 0. So I can pad with 0. Okay, so let's say A is just it's separated into A11, A12, A21, A22, and the B is this right is B11, B12, B21, B22. Okay, and each is A11, A12, A21, A22 is basically the 2-1 minus 1, 2-1 matrices. Okay, now you can assume that the coefficient is integer. Okay, and then you can do the multiplications. So the AB, right? So you can write down the multiplication. And basically it's A11, B11 plus A12, B21, A11, B12 plus A12, B22, and the A21, B11 plus A22, B21, A21, B12 plus A22, B22. Okay, so this is the standard matrix multiplication. So hopefully it's not difficult. Okay, so the strength is very weird. So very weird. Okay, it's very weird why there's a 7 there's a multiplications there's another 7 matrices, right? So there exists another 7 matrices, which is a linear combination of this. So basically, so what I want to say is that these 4 matrices can be composed with 7 matrices, right? So there is a 7 matrices which let's say this M1 up to M2 up to M7, such that these 4 matrices is a linear combination of these 7. Okay, so 4 of them is linear combination of these 7. Okay, so very weird. That's right. M1 is A11 plus A22, B11 plus B22. M2 is A21, A22, B11, and the M3 is A11, B12 minus B22. Don't worry, let me just write it down, and I will do some simple check. M11 plus A12, A1 plus B22, and the M6, M7. So M6 is A21 minus A11, and the B11 plus B22, and the M7 is A12 minus A22, B21 plus B22. Okay, so very strange check is that actually these matrices is basically M3 plus M5, and M2 plus M4, and M1 plus M4, minus m5 plus m7. And the least term is m1 minus m2 plus m3 plus m6. Okay, so let me just do a sanity check. So let's maybe check this. Okay, so m3 plus m5, right? So it's straight. So if I do m3 plus m5, then I get a11 b12 a11 b22 plus a11 b22 plus a12 b22, right? So I can see that these two terms cancel. So it's like a11 b12 these terms. Okay, so we do the first sanity check. Okay, now let's do the m2 plus m4. So I get the a21 a22 b11 plus a22 b21 minus b11, and obviously that this 2 term cancel, so I get a21 b11 a22 b21. So it's really amazing that this is a21 b11 a21 b21. Okay, so now let's check for the first one. So a1 plus m4 minus m5 plus m7. Okay, so we can check. Let's maybe do this. It's a little bit bullshit, right? It's very hard to compute, right? But you can check by yourself. Yeah, so let me just skip, and you can check. Okay, so this is a11 b11 a12 b21. Okay, so basically, what it tell you that is that you only need 7 operations, 7 multiplications. Okay, so now let's go to this, right? So originally, if you do the matrix, do this block diagonal, the block way, you need A multiplications, right? So let's say for n by matrices, you need T of n will become A times T of n divided by 2 plus O n cube, right? Because you need to cube to do just some summation. Okay, so this you can use the so-called master theorem. Okay, so let me just quickly say, right? So the master theorem is basically you can write Tn as A Tn divided by B plus A O n C, and if so, master theorem tell me that tell me what? Let's define as epsilon as C1, right? Write C1 to be as a log BA. Okay, so if C1 greater than C, then T of n will be O of log O of n to the C1. If C1 less than C, then C will dominate. And if C1 the same as C, T of n will be O of n of C1 log n. Okay, so this is the master theorem. Okay, so if I apply master theorem on this guy, then I will get I will get C1 is just log 28, right? So I get 3, so which is the same as this. So the standard will give me O n cube. Okay. Okay, so how about I use the Strassen's algorithm? How about I use this Strassen's algorithm? Okay, so fact, Strassen. If I use the Strassen's algorithm, then my T of n will be Tn divided by 2, right? Because I separate 2, but I give 7, right? Because I only need 7 matrices. Okay. So since I only need 7 matrices, so this is O n cube. Okay, so now if I use the master theorem, so I can apply the master theorem. So master theorem that tell me that T of n is basically this n log 27, right? Because n log 27 is less than 3. Okay, so T of n is n to the log 27, big O. Okay, so this is a Strassen's algorithm that very easy to describe, and it only takes the compared to the original matrix product, you only need the O n cube. Okay, so thanks for you guys watching. Subscribe to my channel. Thanks.